Welcome to today's lesson on expansion and factoring of expressions. These are two fundamental skills in high school algebra that are inverses of each other. Expansion means multiplying out brackets, while factoring means rewriting an expression as a product. Mastering both will help you solve equations and simplify complex expressions throughout your math studies. Let us start with the distributive law. When we have a times the quantity b plus c, we multiply by each term inside the brackets. So a times b plus c equals a b plus a c. For example, 3 times the quantity x plus 4 equals 3x plus 12. The key is to multiply the outside term by every term inside. Now let us look at the expansion of two binomials. When we multiply x plus a by x plus b, we use the FOIL method. First, multiply the first terms to get x squared. Then outer terms give bx, inner terms give ax, and last terms give a b. Combining the middle terms, we get x squared plus the quantity a plus b times x plus a b. A very important special case is the perfect square. When we expand x plus a, the whole quantity squared, we get x squared plus 2ax plus a squared. Notice the middle term is twice the product of x and a. For example, x plus 3 squared equals x squared plus 6x plus 9. Remember this pattern as it appears very often. Another important identity is the difference of squares. When we multiply x plus a by x minus a, the middle terms cancel out, leaving x squared minus a squared. For example, x plus 5 times x minus 5 equals x squared minus 25. This identity is extremely useful for factoring and simplifying expressions. Now let us move to factoring. Factoring is the reverse of expansion. The first step is always to look for a common factor. For example, given 6x squared plus 9x, both terms share a factor of 3x, so we write 3x times the quantity 2x plus 3. Always check for common factors before trying other methods. To factor a quadratic of the form x squared plus bx plus c, we look for two numbers that multiply to c and add to b. For example, to factor x squared plus 5x plus 6, we need two numbers that multiply to 6 and add to 5. The numbers 2 and 3 work. 2 times 3 is 6, and 2 plus 3 is 5. So x squared plus 5x plus 6 factors as x plus 2 times x plus 3. Let us practice factoring a perfect square trinomial. Given x squared minus 6x plus 9, we recognize this as a perfect square because 9 is 3 squared, and 6 equals 2 times 3. So x squared minus 6x plus 9 equals x minus 3, the whole quantity squared. Always check. Does the middle term equal twice the product of the square roots of the first and last terms? Now let us factor a difference of squares. Given x squared minus 16, we recognize 16 is 4 squared. Using our identity, x squared minus 16 equals x plus 4 times x minus 4. Always look for this pattern when you see a squared term minus another squared term with no middle term. Let us now summarize the key formulas for expansion. A times b plus c equals a b plus a cx plus a times x plus b equals x squared plus a plus b times x plus a bx plus a squared equals x squared plus 2ax plus a squared, and x plus a times x minus a equals x squared minus a squared. For factoring, apply these formulas in reverse. Practice recognizing which pattern fits before choosing your method.